Okay, well, good evening everyone. My name is Gorka. I come from Elias Robotics, which is a cybersecurity company focused on robotics. And we are doing penetration testing for companies now. I'm going to explain the robotics capture the flag that we have in development, which is a playground for robot hackers. If you don't know, the capture the flag concept is very used in cybersecurity and consists in finding, by using weaknesses present in different systems, by getting access to different flags that are hidden in different scenarios. In this case, these scenarios, in the flag for these scenarios is is a password. In our case, we have ported this concept and we have ported it to robotics. So all the scenarios are based in ROS and in ROS2. And we are planning also to include more robotics platforms or even real robots. It's open online and it's free, so it's free to use. And in this case, the levels consist in exploring weaknesses that are present in ROS systems and getting the flag for the next levels. So what we want to do with this is we want to get a cybersecurity community that is expert in other fields, and we want them to first learn ROS, then learn different hacking tactics that can be used for ROS and for robotic systems. We want them to explore the already reported vulnerabilities that exist in different robots. And with all of this knowledge, what we want to do is for them to report new vulnerabilities that can be reported through our bounty programs, and we will talk later, and create a community that are experts in robot hacking. This platform is open for contributions, so you can, as you can see in the slides, you can get here you have our GitHub account. You can download these scenarios, and you can contribute to the platform by creating new scenarios with different weaknesses that you have found in ROS or different scenarios that could be done for hacking. You can send these scenarios for review, and we will be more than happy to include them in our platform. So if you want to try the robotics CTF, here you have the URL, and we are more than happy to receive any feedback or any characteristic that you would like to see in the RCTF, or any help that you can provide us. Thank you very much. Have a good weekend.
Tell you're serious because you explicitly say HTTPS. All right, talk number 2 is encoders, and on deck we have JDE Robot Visual States.
Hi, everybody. My name is Alfonso Troya. I'm going to introduce you the project I'm working right now with a friend of mine. It's called Pablo Leiva. And here you can find the links to our profiles in case you want to contact us or whatever. So what's the point of encoders? Sometimes we want to robotize some kind of vehicle or heavy machinery or a forklift or a tractor. And it is really easy to install just some cameras, some lidars, some IMUs, but what about encoders? What about the simplest thing that you should have in a robot? Or like in Ducky Town, they are not having encoders. So for addressing this problem, we are using encoders. Encoders, it is just EMU plus encoders. Yes, we are very original, and we are measuring the rotation of a wheel, and with this, we are able to get an odometry. So we integrated. We made all the sensors. Everything is public and open source. And we integrated everything in ROS. They are completely wireless. And we are not getting just the normal things that you can get with encoders, which is normal odometry, but also you are able to detect the robot kidnapping or drifting. So they are really, really cheap. Actually, you can just get the Gerbers from our public repository. So here we bought a sumo robot, and it is from Parrot, and we integrated it just with some magnets. It is really easy to integrate, as you can see in the picture. And we try to compute some odometry. And here, well, I present you my home. We are calculating just with the movement, and for sure, you just have to set the radius of the wheel you are working with, and also the distance between them. And for the easiest case, that it is a differential odometry robot, you are getting this for sure. This can be used for more complex steerings. And we also present this to the Hackaday contest. We won the Hackaday robotics part, and now we have the final on 22nd October, and we still have to do it. And here there's a link to our public repository. Sorry for the code. This has been done in our spare time. This is not really clean code, but it is working. But everything is documented at least. And also the links to our project in Hackaday and in ROS Discourse. Thank you very much.
So yesterday's phrase was "we are hiring." Today's phrase is "I'm sorry for my code quality." All right, we've got JDE Robot standing right beside me, and I'm sorry, I cannot pronounce this name, from Uselisp, coming up after him. You are three.
Hello all, I'm Okonashik from JDE Robot, and we are actually a non-profit organization from University of Rey Juan Carlos, Madrid. And I'm going to present one of our tools called Visual States. And it's basically a state-based visual editor for behavior generation, and the generated code is actually a ROS package, and it has some features which makes it different from the other available ones. It's a reactive one, and it is hierarchical. Probably all the tools that is available hierarchical, but it enables to import other behaviors into the current behavior, and also it is visual in terms of the editor, and also it has runtime visualizer monitor. So basically we have 4 inputs from the user. First, user provides the auxiliary codes for sensor processing, maybe some action generation. Then we have the actual state codes, transition codes, and the visual design. Then we combine all of them together to create a ROS node. And important feature of this tool compared to other ones is the reactive nature, and all the states have its own thread, so that you can just create a simple behavior like an obstacle avoidance at every level, and it always checks the sensors and always creates an action for the robot. And another important behavior is you can import as many behaviors as you have previously developed inside the other states. So you can cascade as many states as you like, so you can scale the complexity of the behavior by the importing feature. And for the future, we are planning to have the parameterize the behaviors, so that you can just change the parameters to adapt for the new robot, maybe new behavior, and you can use those behaviors which are provided as a parameterized over a repository of behaviors, and so that you can have like a Play Store for the robot behaviors or the App Store for the robot behaviors. Thank you all.
Thank you very much, and thank you for not apologizing. Be proud of the code. Talk number 4, we have Uselisp, and up afterwards is Racer.
Thank you. Hi, fellows. So now I'll tell you about Mami Lapinata Pai and Uselisp. But first, I'll tell you about Terra del Fuego. Now, usually I find it bad practice for the presenter to point at the presentation and say this something, because if you're not looking, you will be lost. But if you don't know it, this is Terra del Fuego. It's like at the extreme south of South America. And it's the terra of the people Yagan, of the Yagan language. The word Mami Lapinata Pai is derived from that language, and is considered one of the hardest words to translate. Allegedly, it refers to a look shared by two people, each wishing that the other would initiate something that they both desire, but which neither wants to begin. Now, it is the kind of feeling which is hardly ever verbalized, mostly because it's too complicated. You have to use too many words, and it's very easy to make a mistake, so you are misunderstood, so it's too difficult. The problem with that is that usually in our day-to-day lives, we ideally would want to use the best words for each situation. In some situations, perhaps the best word might be this one, might be mami la pinata pai, but we won't be able to use it because we don't have it. And we cannot have it because we cannot make new terms at one time, which is a problem. Now, the point here is that not all languages are created equal. Some are better for speaking about some kinds of things than others. And I think that the same thing holds for programming languages. So for instance, we have the Lua programming language, which is in particular good for representing data. It's also good for other things as well. But in particular yet, we have ros-Lisp, which is a Lisp language. Perhaps some of you know of Lisp. Lisp is actually not a language, it's a family of languages. ros-Lisp is one of them. It's a language made for programming robots. And why is that good? First, it's a functional language, which gives you great power. Second, it's object-oriented because, well, you know what that is good. But besides that, it's Lisp processing. In particular, the program itself is a list, which gives you, the programmer, a great introspection, which means that you can make what I think a programmer should ideally make, that is design new languages. When you work on a particular problem, you want to use the language of the problem, not the language which you are constrained to. So yeah, we have still some seconds, so great. Now, if you don't know Lisp, this is a silly program on Lisp. Yeah, quite easy. So we have still more than 10 seconds. Do someone want to make a question? Thank you.
Check. I suppose you can find him at the coffee break to ask both about use-Lisp and incredibly difficult to translate words. Possibly Trivial Pursuit tips. Okay, up right now we have Racer, and on deck is ROSCon funding for ROS developers and users. Okay.
Okay, so hi, I'm Mateusz, and I wanted to talk something that was inspired by the early morning talks yesterday, actually. So shout out to all the people that did that work. I would really use it at some point. So what I'm going to talk about is about the project that we got funded by European Space Agency. And the basic question we got is how fast you can drive a rover, teleoperated rover, on Moon. That was the question we got. And we did this project with our subsidiary, PeopSpace. So we started on very tight schedule last November with basically Scout. This is a EOD, former EOD rover. And by December, we had some quasi-lunar simulation. And then we had early this year some basic prototype for what we want to use. And 2 months later, we have the ready version of a system which consists of the rover and the operator console. And this system is not very simple. But thanks to ROS, it was quite easy to do. Maybe only difficult part was this data link in the middle that we wanted to simulate constraint like delays up to 5 seconds and low data rates. So we used 2 ROS bridges tied up together and UDP messages to make that work. That was certainly a challenge. But just to separate your system from the console and for the robot and the bridges inside and make it work. With ROS2, obviously, there will be no issue. So with that, we went to a quarry, and thanks to some people there and their equipment, and thanks to some of my team that literally lifted rocks, we built the test site. And we started to driving. So what operator would see would be something like this. Multiple screens, robot data from the 3D sensor, from the cameras. This is actually an example from the simulator, but in the real, I didn't have a screenshot for that. And obviously this is for higher data rates. So with lower data rates, there was certainly much less things to see. And this is the kind of the mission they would do. And we started to drive. And we drove during nights, which you don't see much, but it looks like a moon. And during days. And we did that for like 2 weeks. And after that, very exhausted teams, team of operators and engineers finished the project mainly. What was left was to write the reports, and we were very happy with the results. So shout out to all the contributors of the ROS and simulators and stuff like this, because we can do it thanks to you. And what are next steps? So hopefully, with the contract extension next year, we will go with the bigger robot. Thank you.
I'm enjoying how people are speaking faster and faster and faster as they watch the clock. Okay, up behind me we have ROS in funding, and on deck we have ROS and construction robots.
Thank you very much. I'm Carlos Hernandez from TU Delft, and I have to thank Dave Coleman for the very inspiring talk before and for laying the ground for this speech, because how many of you, and please raise your hand, would like to improve the usability of your packages? Have them ready to work on that? Because, okay, good. And how many of you are in Europe, working in Europe? Okay, that's quite some people. So maybe you are interested in the tool I have for you, which is money. Sorry, funding. We have over 3 million to do exactly that. So if you are interested, please come talk to us in our booth. Is the ROS Industrial booth with our colleagues from PILS, which have already received this funding. And maybe we can talk on how you can use our funding to improve the usability and increase the use base. I think I might have some time left, so maybe you want, I can explain a bit why we are doing this. We want to move ROS to the industrial use, and we want to make it the digital industrial platform for robotics in Europe. And we have this funding schema that basically funds this moving from the prototype, the concept, into usable components. And we know that requires time and budget, basically. So we hope to provide for some of that budget. So we fund 1/3 of such project. It needs to be open source, contribute to the community. We aim for small projects that target specific needs by industry, and we understand here the broad concept of industry is not just industrial manipulators, any commercial use case. And as I said, unfortunately, this is European funding, so only European entities can apply for. But for all of you that are not in Europe, I hope you take quite a look at the people that raise their hands, because you can collaborate with those people because they have funding at least to cover their jobs in the project. So just check who has now funding available. How you can apply for this? Just go to our website. It's continuously open, so you can apply anytime. From time to time, we check which projects are there, we evaluate them, and we fund those that are suitable, basically. So it's first come, first served. So apply now. The next date in which we will start selecting a project would be November 16th, but we will continue next year till we run out of funds. So be fast doing this. And we have funds not only for this, but also for education activities with ROS, because we want to increment the user base and developer base, both in academia, but mainly also in industry. So we have some activities there. These are, I think here there are 15, but we have already funded more than 20 projects. You can find some of them here at ROSCon. Thank you.
We're still part of the Commonwealth. Does that count? Kind of, okay. All right, we have ROS and construction robots up here, and on deck, ROS goes underground.
Hey guys, I'm Andrew, and I'm with Build Robotics. And what we are doing is we are automating construction equipment. So basically, we're taking existing construction equipment and we're putting our own hardware and software on top and having it drive around and move Earth autonomously. And our thesis is that with automation, and excavation and construction can be faster, cheaper, and safer. And there's a real problem right now in the United States, especially where there's a significant labor shortage. There's some crazy stats where it's like the average operator age is like 46 right now, and like 70–80% of firms are having trouble hiring skilled talent. Talk really briefly about the technology that we've got. It's fully autonomous. That's come up a lot. But basically, what we do is we load in basically a CAD file of what the ground should look like, and it'll understand that, and it'll also figure out what the ground currently looks like, and it'll cut and fill accordingly. So the end product is basically a final product that we can deliver to excavation firms. And I've got a quick time lapse here. It's kind of an older video. I'm hoping that it loads. All right, cool. But it's an older video, about a year and a little bit ago. It's a time lapse that we've got. And so this is Marianne. She's our compact track loader. Actually, ATL, so autonomous track loader. But basically, it's a compact track loader that's been outfitted with our sensors. You can see it's going into the dark without any brakes or anything. And at the end, it's just a set of eyes. But basically, that was cutting out a housing pad about 100 feet by 60 feet and about 3 feet deep. And that is cutting to an accuracy of 0.1 feet. And I apologize that we're using feet here. We're doing construction in the United States, so I've had to sort of switch over to feet. Yeah, and we are hiring. We're based in San Francisco. We raised over $15 million from some of the top venture capitalists in San Francisco, and we're hiring across all departments from engineering to operations. One thing that I forgot to mention is that where we are in terms of technology is we've actually got equipment out on the fields. They're deployed long-term out in the fields, and we've got operators running it instead of engineers on site. So big moves. But yeah, so you can, I've got a little bit of time, but we do fun stuff. So we've got a picture of the team doing an offsite where we're dirt biking, and then the bottom picture is actually a picture from a drone shot from one of our sites. You can see we're cutting out housing pads. You can also see the streets. It's pretty cool stuff. So pushing a lot of dirt, moving a lot of dirt. So yeah, thank you.
You wanted to use every last second there. I volunteer in my backyard, by the way. All right, up we have Ross goes underground, and on deck, functional mock-up units.
PowerPoint, please, not the video.
Oh, you have two. You like to live dangerously. One moment here, will I just fix something? Okay, that's probably not going to. That's. I'm told it should be faster.
Okay, hello everybody. My name is Robert Lösch, PhD student at the Technical University of Freiberg, Germany. And it's a mining academy, and we do, as you can see, underground robotics. When a robot wants to be helpful in a mine, he has definitely navigate through it. And at the computer science department, we use a robot you saw some seconds ago, and we call it Julius. And in this video, you will see a lot of what happened in an earlier navigation test drive, which happened in the old silver mine in Freiberg, and it actually belongs to the university. And to accomplish the navigation task, the miner can put a waypoint on a previously acquired map via an ARVIS plugin. And to localize itself, the robot uses an RGBD camera, a Kinect version 2 on front, using optical features required by an image stream. We also use LiDARs. We have a SIG LMS mounted front and back at the robot respectively, and one 3D scanner mounted on top of the robot. And you can see the point cloud at the top right corner of the video. Okay, we're using this sensor data, the global map and the waypoints. The robot is able to path its plan through the mine using the ROS navigation stack. And as you can see, the robot is no drilling robot, so he cannot drive through the walls. And to prevent this from happening, to prevent collisions with its surroundings, We use the robot's dimensions and take the local cost map into account. You can see it on the right. And I guess probably nobody of you has experience with underground environments. So for those of you, there's no GPS, you have a high humidity, you have usually a typical short line of sight communication capabilities, bumpy and slippery floor. And sometimes tracks and often safety and logistical constraints. And if you have experience with these things, then talk to us. And we are really want to know your tips and tricks and already working solutions. And if you want to need, for example, backfiles from the mine, we can help you with that. Or if you plan to compete in the DARPA Subterranean Challenge and want to test your robot in an underground mine, you can also talk to us and test your robot. And we can figure something out. So to sum up, our robot is capable of driving autonomously underground thanks to ROS and uses its sensors efficiently. And if you want to help us or we can help you somehow, please talk to me and my colleague during the day. And one more thing, we also wrote a paper which presents the robot, and we present the paper Tuesday after lunch in the Amsterdam room at IROS. Thank you.
Thank you. Let's see. Looming ominously behind me is functional mock-up units. And next up, we have the autonomous tree pruning UAV.
Hello, I'm Ralph from Bosch Research and would like to present a new package called FMI Adapter. The story is told short. We had a control engineering student last winter who did a great job in designing a complex state estimator for one of our mobile platforms. And then we asked ourselves how to bring it on the ROS system, because he did his work in a cool tool called Daimola. That's a modeling tool from Dassault. And that was the birth of the FMI adapter. So FMI stands for Functional Mockup Interface. That's a standard for interchange, exchange, and co-simulation of physical models from typical modeling tools. And it's supported by quite a number of tools, including MATLAB Simulink, Daimola, OpenModelica, Simulation X, Wolfram System Modeler, and many, many more. And all these tools allow to export physical models as a called functional mockup unit. That's technically a zip file, which contains a shared library containing the equations, input-output variables, a numerical solver. Of course, they have to adhere to a certain interface, provide functions to set these variables, to do steps, to read the variables. Secondly, it contains a model description, which gives the names of the variables, step sizes, parameter default values, etc. And it may contain the C sources of the shared library. And the FMI adapter package provides a node that takes such an FMU and maps the FMI concept to the corresponding ROS concept. So there's a subscriber being created for each input variable with the name of the variable. Similarly, publishers are created for the output variables. Parameters can be read from the parameter server, and starting such a model with this node is just a one-liner. In addition, we provide a library where you can do more advanced things. You can introspect the FMU, can get the variable names, the parameter names, etc., manually trigger steps. Documentation is given in the ROS wiki. You can download the latest version from this URL at GitHub. There are also some examples included for standard Linux with ready prepared FMUs, instructions how to create your own FMU, try it out, and contribute if you like. Thank you.
Almost sounds like it's good code. Okay, we have the autonomous tree pruning UAV, which I'm kind of afraid of already. And on deck, we have open source 3D obstacle recognition applied to power line robot inspection. Okay. Do you want the PowerPoint first? Yeah.
Hi everyone, my name is Sam Schofield and I'm from the University of Canterbury in New Zealand. So the goal of our project is to automate tree pruning for the forestry industry using a swarm of autonomous multi-rotor UAVs. So the reason why we're using aerial vehicles instead of ground vehicles is because of the environment we're operating in. The ground's covered in obstacles like rocks, fallen trees and branches, and undergrowth. Additionally, a large percentage of our forests are on hills that look like this. Using ground-based robots really isn't feasible. So this is our current prototype. You can see our pruning tool for cutting branches hanging out the front. The pruner itself weighs about 500 grams and the whole UAV weighs just under 5 kilos. Here's a video of our cutting tool in action. It's set up to automatically prune a branch when it comes into contact. Here is a video of our first successful fully autonomous cut. The pruner is actually on a servo which makes small adjustments to make sure the pruner comes in contact with the branch. And here it is pruning all of the branches on the tree that we've got in our lab. So this flight was controlled entirely by the onboard computer. So the UAV takes off, it carefully positions itself perpendicular to the branch it's going to prune. It then moves in and performs the cut and then circles around to the next branch. We cut 3 branches in this video, but we can feasibly do as many as we like, limited only really by battery life. So that's our progress so far. What we're currently working on is getting this to work outdoors in a real forest, which is going to be a bit of work. Yeah, so that's everything from me. Thank you.
I have no words. How could this possibly go wrong? How many times have you played Half-Life? Did we have talks on safety? Did we have enough talks on safety? All right, so now this looks like flying around power lines autonomously. Are you trying to one up him?
Yes.
Okay.
Yes. Sorry. Yes. Hello, everyone. First of all, I'd like to thank you the opportunity to meet all of my ROS idols in the real world. So my name is Matheus Nascimento. I'm from the Brazilian Institute of Robotics, and I'm going to present you to my bachelor project that I work at. So, sorry. So in Brazil, almost 38% of the energy distribution is based on power line transmission. So every day, a professional, it doesn't work. Everyday professionals jeopardize their lives trying to keep the security of the line. So based on that context, we are developing an autonomous robot that aims to develop a visual and thermal approach to do inspection. So I was responsible for the perception module that is based on 3D vision. So this is our laboratory and some of equipment that we have been using. So on left, we have the obstacle that we considered, and here the kinetic version of distribution of the ROS based on Ubuntu 16, and we use C++ language and in Python as well. So there is a kind of delay. So this is the chosen stereo camera because this camera has all features that is compatible with our project. So we have the architecture that we consider to this project. So basically, we have the obstacle detection model that have to detect the objects, and the obstacle classification model that was based on 2 approaches. The first one is based on the machine learning algorithm that is also known as KNN, and you already know about that. So the other one was based on the deep learning approach. So we've used the AlexNet architecture and the Google Net architectures as well. So here is a sample of the obstacle modeling. So hold on to the delay. So So here you are the video. So these are some steps that we made using computer vision's approach to detect the obstacles. So there is another sample. Just a minute, please. So the time is running. Yes, so here we can see the depth map and one of the obstacles that you have to detect. Here you are. So you have to notice that we have some kind of noise in this image, and even in this way, we have good results. No. Just one more thing.
Excuse me.
Hold on. Yes, I received rare proposals.
And Sam with the tree pruner, please never download his code. We don't need to mistake for the power lines. That would be unfortunate. All right, we have 3D Co Auto Sim, and on deck we have Universal Robots talking about drivers. Ooh. I heard that.
Okay, so let's go right into it because time is running. So my name is Ahmed Hussein. I'm going to give you a presentation about a 3D Co Auto Sim. It's abbreviation for 3D Simulator for Cooperative ADAS and Automated Vehicles. It's a little bit similar to the lightning speech of yesterday, which we have as driving simulators that use both Unity and ROS. Unity for visualization and ROS for planning, control, and so on. And the main idea initially is that we wanted to use this simulator for driving behavior analysis, and we wanted to see how we can use this simulator to have the driver sit in an autonomous car, how he will behave with some other feature of ADAS, and so on. When you launch the simulator at the beginning, you welcome with a configuration menu screen, which you can select different features that you want to test. So your test subject and what type of sensor or devices that you want to install. So it's designed in a modular way. And since it's driving, so this is what the other view is what the driver can see. And since there is driving involved, actually, we needed to have a platform. So this is a platform that we're using where you have a CarPlay seat, steering wheel, gear shifter, and pedals. And of course, we have 5.1 sound surround systems that give you the feeling that you're sitting in an actual driving environment. But since we connected it to ROS, we didn't want to stop there, so we want to take it to a next level. Why don't we actually start testing this car to test because we have an autonomous vehicle, I want to test our algorithm before deployment in simulation. So from this sense, we wanted to have the vehicle kinematics and dynamics, everything modeled inside it. And we have the scale of all the cars developed inside the Unity and connected to ROS. And you can see from this photo, for example, we selected 32 layers Velodyne and a monocular camera, and you can select different devices that you want to install, different options that you want to have, put it in different location for your system, and it will link to ROS. And you don't have to have this car, you can have different cars, we have different options that you can have, even a truck. And you see here also as well, we can have a traffic light simulation and other NPC cars that are working in the environment. And all of this, you have it modeled with Sumo and OpenStreetMap. The OpenStreetMap point of view is that actually you can select a map in the environment anywhere in the world and link it to City Engine. It will give you the 3D buildings of your environment, and then you can drive in a place near your working environment that you're actually in. And with Sumo, it will simulate traffic and control the traffic lights, so it will actually simulate everything to the needs that you have. This work actually was validated and submitted to a work that was accepted in IEEE ITSC 2018, which is going to be presented this next November in Hawaii. And since we're running out of time, that's it. You can have this GitHub link, which you can download it. And I'm actually applying, not hiring. Thank you.
I've seen a lot of great car simulated videos, and I've actually never seen a Mario Kart one, and it kind of disappoints me. All right, we have Talk 14. You have no slides.
I do have slides.
You do have slides?
In the browser, there should be.
Oh, the browser, right.
Hopefully.
There we go.
Yeah, here we go. Can you wait on?
I think that's the button. All right, and on deck is a Gauss 6.
Hello, my name is Marek Cygan. I work at No Magic, which is a Warsaw-based startup where we are focused on manipulation in the context of e-commerce warehouses. So even though we have been founded only in June last year, we are already entering our first pilot with a Cdiscount, which is a French e-commerce company. You can see our robot, which is picking, scanning the barcodes, and putting them into boxes, which are then shipped to clients. As you see, we're using UR10. And here you can see how our robot is emptying a cart. So the challenge is that the products are cluttered, and there is a large variety of the types of objects that we need to handle. And the reason why I'm talking here is that we are using UR10, we are using ROS. And then when we started using UR10, we decided, okay, how are we going to control it? And most of the times we are using linear movement, either in the joint space or in the Cartesian space. But sometimes it is beneficial to use planned movements. And then we would like to use MoveIt. So we inspected what are the drivers that are available. Initially, Universal Robots was supporting a driver for UR. Then it was supported by the community, which was a great work, but still it was not perfect. And the problem we faced is that MoveIt provides us with a list of points, like a course trajectory of poses and velocities, which would be roughly 20 to 40 points on the trajectory we're interested in. And what happens in between is that it is an interpolation, which happens on the external PC. And in the loop with the rate of 125 Hertz, you transmit over TCP what should be the next position. And things can go wrong even if you are on an Ethernet, because when your packets are either lost or batched, then it might happen that the robot tries to move very fast to the next position because it thinks that the next position is super close, but it's actually very far because it lost some packages on the way, which makes the robot enter the protective stop. So our contribution is we prepared a new driver, which we open sourced. And the difference is that now the points in between the points of the trajectory are interpolated on the UR control box. And as a result, we obtain smooth movement, even if the robot is controlled over Wi-Fi. Thank you, and obviously, yes, we are hiring.
The conference is now approaching self-awareness. All right, last up is Go 6, I believe. The video or PowerPoint?
Hello everyone, I'm Jake Zhang from Tony Robotics. We developed the RoboWare and IDE designed for ROS, and now it's open source. It can be found on GitHub. Also, we promoting ROS in China and have done some ROS training and education. As you know, a 6th degree of freedom arm is needed for training and education. We need it to be driven by ROS. There are several open arms online, but some don't use ROS and some are not products. Also, the general 6th degree of freedom robotics arm is expensive. So make one by ourselves for training and education. Girls 6. We make a low-cost arm. It's 3D prinable and step motors with integrated station systems and drivers. It's suitable for training and education, fully controlled by ROS package, including MoveIt and ROS controller. And IKFast and KDO are installed. There are many colors to choose. Of course, you can choose your color you like. We provide many tools for implementing you understand the tasks. This is the software. It can do status monitoring and configuration. It can be remote control and teach and play. You also can program with Broccoli. Show the video, please. Yeah? Okay. It's just a simple demo. Okay, thank you.